Good evening, everybody. Welcome to the third of our online lectures from the Royal Aeronautical Society Boscombe Down Branch. My name is Jeff Clarkson. I'm the Vice Chairman of the branch, and a great pleasure later on to introduce our speaker, who's going to talk to us about the TSR-2, the bomber that barely flew. Now, this aircraft, as I'm sure you probably realise, has a quite an emotional feeling for a lot of people. At Boscombe Down, it was the last aircraft in reality that made its first flight out of Boscombe Down in the conventional sense. And in 2016, we did erect a plaque covering all the aircraft that had made their first flights at Boscombe Down. And of course, the TSR-2 in 1964 was the last one that made it in that sense, and so that fulfills it's the last entry on our long list of aircraft that made their first flights at Boscombe Down. So we're looking great intent there to hear later from our speaker on that subject. So our speaker tonight is Joe Jackson. Really glad to welcome him. He's a 28-year-old engineer with a passion for aviation and public speaking. He studied engineering at Loughborough University and went on to work at Rolls-Royce, developing jet engines and assembly teaks across both the UK and Virginia. And in his spare time, he flies a Cessna, which obviously you can see in the picture there, and getting out on his road bike. So in just a second, we'll be handing across to Joe. So welcome, Joe. Thank you very much. Look forward to your talk.
Thank you very much for having me. It's an honour to be here. It's been a long time coming, I must admit. This was something that I started. I'm just going to load up the presentation, hopefully to give everybody a flavour of what's to come. This is something I started 3 or 4 years ago now, when I was at Rolls-Royce as a graduate, and I joined the RAS lecture competition. And this was I had to do a 10-minute one there, so slightly more controlled on time. But this was my kind of bid in the competition, which went very well. And yeah, it's been something I've kind of been following for as long as I can remember, really, since a trip to RAF Duxford, where I saw XR222, I think it is, in the skin over there. So the TSR-2, for those, I'm conscious we probably have a mixture of an audience, some who will know far more than I do about the topic, and some who might know a little bit less. So I'm going to try and find a balance in between bringing everyone up to speed and adding enough technical detail to keep everyone engaged. But the TSR-2, straight off the bat, it means Tactical Strike Reconnaissance Mach 2. So that was the idea that the TSR-2 was designed to solve. It was, to be honest, it was a plane. It was an everyman's plane. It was designed for all roles and all functions. But we'll go into that in a little bit. A little bit of background, as I said, I'm an engineer. I've had a passion for aviation for as long as I can remember. I originally wanted to be a fast jet pilot before the RAF didn't look like an option I could pursue at the time. The reason for TSR-2, as I said, going around museums with my parents when I was young, it's always interesting looking back before you it prompts you to research before you start looking forward. And I remember seeing the TSR-2 at Duxford and thinking it was the most incredibly, almost odd looking aircraft. The more I dug, the more I realised what an incredible aircraft it was. And then kind of couldn't believe the story that that unfolded in front. So this is my little version of that, and certainly it's important to say, fully recognising I'm lecturing the Boscombe Down contingent. There's a wealth of information I'm sure people have far more so than I do, and I look forward to a kind of a healthy discussion at the end to learn as much as I can about it. So please do bring your questions, and if I get anything wrong, or if you feel there are things I've missed, please do let me know so I can be better read for next time. And kind of notes on copyright, no infringement intended. They're all images and information is kind of open source. Right, so the TSR-2, what it was. Well, first and foremost, it was a project of incredible ambition from an engineering perspective. It was an aircraft deserving of a worldwide superpower that we were at the time. And the kind of the variety and depth that our aerospace industry had is a reflection of that. Just if nothing else, the sheer number of companies we had across the United Kingdom manufacturing world-class aircraft. What's interesting with the TSR-2, it was ridiculously ambitious in a time of a very politically balanced and fragile environment, and in this case hostile. And so it really kind of begs the bigger question: how did this project go from a $200 million world-leading project to 50k in scrap? And what happened along the way? Well, this particular story starts back in September '57. The GOR 339, so GOR means General Operational Requirement. A 48-paragraph document was released in September '57. And this GOR spoke about the requirement for a tactical strike reconnaissance aircraft, something that flew high, flew very low, flew very fast, very low, and could deliver, when needed, nuclear payloads on a specific target and get out of there, basically. This was at a time when the head of the MOD, Duncan Sands, produced a white paper detailing the sole prevailing requirement was V-force bombers, and that the remainder of the future fleet of the RAF would be missile systems. So already we're kind of setting the scene of an anti-aircraft environment. On top of that, as I mentioned, the UK had a very rich heritage of aerospace manufacture at this time, and we'll look at a list of some in a few slides. But one of the requirements for this particular project, which hadn't really happened before, not to this level, was the awarded contract would be to companies that had to band together. The government viewed the aerospace manufacturing market as oversaturated, and they were adamant that they were going to do something about it. A little view of the timeline. You'll notice at the bottom of the slide pack there is a timeline. Hopefully that will kind of place us as we go through this journey. But a few key dates to look out for. The contract was awarded in '59. That was the planned contract. It was actually awarded in 1960. The first flight was planned for 1963. It actually happened a year later, with a planned introduction into service in 1966 for a planned cost of 16 to 35 million. Having been working in aerospace for the last few years, looking at those dates, it is quite terrifying to think that they were going to not only design a new aircraft, but a new engine in that space of time. I mean, it's eye-watering. The fact that they lost a year before the contract was even awarded means they started off on the wrong foot. Regardless, 11 companies ended up competing with kind of countless hours of work, and they published what was called a brochure. So they put forward their brochures at the time, showing the best of what they had to compete for this TSR-2 contract. A few stand out, which I'll kind of talk about. The Blackburn was one of the major competitors with the Buccaneer. Now the Buccaneer was, although it was regarded by some that the RAF didn't really consider it, a lot of internal RAF air marshals said that they very much did consider it, but they were conscious of its competition at low speed. So they're worried it wouldn't quite fit the profile that was required for this tactical strike. English Electric, who really were the only company here to have heritage with the supersonic realm, having made the English Electric Lightning. It's, lots of people, it's widely considered that they should have got the bid because they had, up at this point, 10 years of supersonic experience with the Lightning. They also built the Canberra, which was what this whole aircraft was designed to replace, which had been wildly successful across the UK, flying all over the world and selling all over the world as well. But it's interesting, they were kind of considered by many as an industry newcomer, and I'm sure resented, and there was some contempt for that, for English Electric because of that. As a result, the primary contract was given to Vickers in collaboration with English Electric. I should just note here, the English Electric bid was the P-17. They teamed up with a company called Shorts Brothers, who were creating the P-17D VTOL platform. The idea was that this platform would offer the VTOL capability required of the TSR-2. We'll look at requirements on the next slide. but it had to go up and down, VTOL, vertical takeoff and landing, and also fly supersonic. So that was their bid. And Vickers, who had their main experience with the Valiant, which is widely considered to be not a successful aircraft. Despite all of this, the main bid was given to Vickers in kind of collaboration with English Electric. What was interesting is the two companies hadn't put forward similar designs at all. So the fact that they then had to amalgamate and cooperate to design this aircraft already started on the wrong foot. But the writing was very much on the wall with this. It was amalgamate or die. That was how the GOR 339 was set out, and that's how all the companies saw it. So they didn't have a choice. The government had cornered them. So, as I mentioned, the idea here was to upgrade from the Canberra to effectively the supersonic Canberra. GOR 343, which came out 2 years later, was 114 paragraphs, so it had a little bit more meat to it, and it basically went into detail stipulating the requirements of the TSR-2. Someone, I think it was Roland B. Bowman, who's the chief test pilot of the TSR-2, basically said that the TSR-2 and the Buccaneer were the only game in town. So if it was designed to be in an aircraft, it was thrown at it, and that really was reflective of the spec for the TSR-2. It was an everyone's aircraft, every man. It had to have a 1,000 nautical mile range, which could be increased with tanks. It was designed to fly at Mach 1.1 at 200 feet and Mach 2 at altitude. It could carry tactical bombing and nuclear payloads when required. It had to have reconnaissance capability. Now, it's worth just kind of talking about this, and we'll talk about the technology in a bit, but the reconnaissance was a huge part. They needed an aircraft to fly in challenging conditions and therefore redevelop and redefine a new radar system to make sure it could do that safely in all weather, at night, and through harsh terrain. None of this existed before the TSR-2, and I had to do all of that flying faster than any aircraft and delivering a nuclear payload. So it was a tall order. Straight from the off. Equally, it had to ideally have vertical, if not short takeoff, and soft field landing, and that put a huge amount of design pressure on the landing gear to kind of get that right, because balancing an aircraft that flies supersonic and can fly very slowly and land on a variety of surfaces is no easy thing. We kind of talked about this high resolution radar, this reinvention of a new radar. Basically, it would have a head-up display, and already the initial costing, as I said, was 15 to 35 million. The development estimates in 58 had already doubled to 70 or 80 million, and it obviously turned out to be far more than that. It was also meant to be flown by a two-man crew. So one could kind of say that looking at that requirement spec, the writing was on the wall of where this project was going to go. It was facing a huge challenge from day one. Here's a lovely photo just to orientate everybody. We've got the Canberra on the left there. That was the aircraft that the TSR-2 was to replace. In the middle right is the English Electric Lightning, at the time the only supersonic aircraft that was designed and flying and commissioned. And then the TSR-2 up at the top, that kind of huge white elephant. Right, so the marriage of inconvenience. As I mentioned, the government were insistent that the companies banded together. Now, on the 1st of January 59, TSR-2 was born. Designs were submitted in 59, and on the 1st of January 1960, BAC, British Aircraft Aeroplane Company, was born. Now, BAC was born between Vickers, English Electric, Bristol Airplane, and Hunting Aircraft Company, but they had a number of contracts, and this was the contract being worked by Vickers and English Electric. So what they did, they split up the design requirements between the companies. English Electric would look at the wing, rear fuselage, empennage, and engine install, and Vickers would look at the nose, centre fuselage, and avionics. In the end, Bristol Siddeley won the contract for the power plant and an Olympus engine, and they basically designed a brand new engine for the TSR-2. Already tempers started to fray. The two companies didn't see eye to eye from the off. They thought that the amalgamation hampered progress. You know, they each had their own heritage in aircraft design and weren't kind of used to playing with other companies, which, you know, looking back, I completely understand. And not only that, but the way that this project was set up, it meant that the MOD and the MOA, the MOD is the Ministry of Defence, the MOA is the Ministry of Aviation, they were very much in control at every turn, despite having BAC as the owner. For example, most of the subcontractors reported directly into the MOA, not BAC. So they were trying to pull this incredible project together, and they didn't even have control of a lot of the subcontracted components. And I believe the phrase "a camel is a horse designed by committee" has never been more true than for something like the TSR-2. So kind of winding the clock forward, we're looking at really the 4 years of design that went in between 59 and 63, maybe kind of tickling in 64. For those who aren't kind of you know, aircraft designers like myself, I thought I'd talk about some of the greater challenges, the technical challenges that the TSR-2 really posed. We mentioned this kind of short field landing and rough field landing as well. This was difficult because you're designing an aircraft that has to fly at MAC, which means it needs to carry a lot of fuel on board to be able to actually complete a bombing sortie. So you've got a very heavy aircraft, a very big aircraft, and you're trying to land it on all sorts of kind of landing. Now this, all sorts of surfaces, you know, whether it's fields or beyond. This was mainly put in the spec because the ministry were worried that the Russians would knock out airfields, and so they had to have an aircraft that could handle adverse conditions if the airfields are under attack. So it's a really interesting design problem, and they had lots of issues with the landing gear. In the end, they had something called a double cycle closing, which is when the landing gear were down, they would actually close the a lot of the kind of periphery flaps around the landing gear to reduce drag, you know, and all these things just add an extra layer of design complication in on top. It was also difficult because they had to look at low pressure tires. When you're landing on uneven surfaces, you need a softer tire to be able to absorb the difference in the surface. The problem was, you also, whenever you give an aircraft an airworthiness certificate, it needs to be able to land at all but full weight in the in the circumstance of something like an emergency landing. So designing the landing gear to be able to handle both situations was a huge problem. Looking at the wings as well, designing an aircraft for supersonic flight and slow flight are two contradictory principles. When you're looking at fast supersonic flights, looking at something like Concorde, which I'm sure everyone can picture in their mind with the big delta wing, and English Electric's Lightning, you tend to have a very swept angle. Now this was because it helped reduce drag at high speed. So having a wing that would perform at supersonic flight and also at low speed was an incredible design challenge. And the TSR-2 got over that by using something called blown flaps, which is where you pipe off some of the compressor air from the engine and you pass that through ducting over the flaps, and that helps lower your stalling speed to give you more kind of work. It gives you the ability to land safely. And talking about that short takeoff and short landing, you need that element of slow speed to be able to stop the aircraft in a timely manner as well. There were also revolutionary avionics. There's a slide on that coming up, which I'll kind of go into a bit more detail on, but putting an aircraft through low-level terrain at very fast speed using the avionics of the day would have been probably an insurmountable challenge, which is why they had to redefine the rulebook on designed avionics, which is fascinating. But to be honest, one of the biggest design challenges that the TSR-2 faced was the management. There's kind of this discussion of an American style management coming in, which was a bit more kind of rambunctious, I guess is the word, is a bit stronger willed. And there were some fascinating stories that came out. One of which was there was a meeting going on at the MOD, and the chair sat down. He looked around the room in these kind of big meeting halls in St Giles's in London, and he asked for a count to be taken because he thought there were a few too many people there. The count came in at 58 people at the meeting, in a design meeting. So he said, "This is insane. We're not going to have a meeting under these circumstances." They organised another date to have the meeting, and he requested that only necessary people attend the following meeting. Wind the clock forward, the next meeting comes around, and there were 61 people at the next meeting. So designing an aircraft under that, doing anything in those kind of conditions is incredibly difficult, let alone the technical challenges that this particular project held. Another example here was the fuel system. So to give you an idea of how the two companies and the MOD integrated, the BAC had kind of evolved a capacity gauging system. So this is something that Vickers really brought in, which is where the pilot switched between the tanks and the navigator trimmed. So it was more of a manual system. English Electric preferred a flow meter system where they would kind of live flow meter the fuel between the tanks to ensure balanced aircraft. The MOA led the committee on the fuel system, and they adopted both the gauged flow meter system from BAC and from Vickers, and the flow meter system from English Electric, and they added their own automated comparator on top. The point is, they made something that should have been simple. They made it 3 times more complicated than it needed to be, adding time and money. So the power plant was really a bid between Rolls-Royce at the time and Bristol Siddeley. Both engines were assessed. In the end, Siddeley was awarded the contract in January 1959. Now, this came as a surprise to everyone in the industry. Rolls-Royce had put forward an engine that was flying, for one. It had achieved its airworthiness certificate. It was a proven engine. And as Roland V. Beaumont says, you should never mix a new airframe with a new engine because you're asking for trouble. Too many variables. Engines are very difficult things to get right, as are aircraft. So adding the two together was the challenge was kind of set very, very early. So what happened? The MOA requested an Olympus 22R, is what we'll refer to it as from here on in, but it was the Olympus 22R twin spool jet engine. Now, they had taken what was a 100 series engine that was flying successfully on the Vulcan, and that was putting out about 11,000 pounds of thrust, and they were making this engine supersonic worthy. So they were adding, this was the first twin spool engine of its day. Adding a spool, adding a kind of a low pressure system into an engine is not an easy thing to do. You add a huge amount of design complexity and risk when you do that. And when Rolls-Royce designed the 3-spool system in 1972, it bankrupted them. So gives you an idea of the level of challenge that they were dealing with at the time. Regardless, they pressed on with it. This was going to be the first Olympus with reheat as well. So reheat is the afterburner. They had to increase the LP shaft to accommodate for this new kind of twin spool design, which led to its own issues of vibration, mainly from reheat overfueling. But what's amazing is they took an engine that had 1 spool that wasn't designed for supersonic, that had 11,000 pounds of thrust, and they redesigned it to a 20,000 dry thrust and 30,000 wet thrust, so with afterburner. So they tripled the power of the engine. All of this was on an engine frame, the 100 series, which had known issues as well, which later cost them dearly, which we'll talk about. Not only this, but testing an engine like that hadn't been done before. So over at Pystock in Farnborough, which was where the testing facilities were, they had to build a new way of testing a supersonic engine like this. And to do that, in particular, they had to heat up the supersonic air going into the subsonic air and the supersonic going into the engine to reflect the temperatures the TSR-2 would see in flight. None of this existed before. So they were rewriting the rulebook on every level. And interestingly, for those that may not know, after the project was cancelled in 1966, Rolls-Royce actually bought out Bristol Siddeley, and they became one. Alrighty, so the cockpit. The cockpit's another great example of kind of this challenging management environment that surrounded the TSR-2 and these battling companies with the government. They would kind of talk about 60-person meetings and days to decide the location of every switch and whether the switch should have a label on it and what that label should say and all the rest of it. Compare this to Rolly Fulk, who was the Vulcan chief test pilot, who fought adamantly, but he fought and won to design the cockpit himself. And you know, that makes a huge amount of sense. When you're the customer, you should be designing the interface that could, it's not just important in how you do your job, but it could save your life. So it's incredible. It's incredibly important to get that insight from the people who are going to use it, and that didn't seem the case with the TSR-2. And in fact, an interview with Beaumont, the chief test pilot, he kind of spoke about how they had to change a few things before the first flight to make sure it was actually safe to fly. Now, the TSR-2 did have its own challenges where they were introducing a huge amount of new technology, which was all reflected in the cockpit setup, and I'll pop an image up in a second. But new things that we've mentioned very briefly, like the ground following radar, and the AFCS, the Automated Flight Control System, all these things were new, so they had to find a kind of an ergonomic home for them. But to compare, on the left, the TSR-2, you've got the pilot in the top left, the pilot's cockpit, and then the navigator bottom left. Compare that to the Vulcan. There's a very different feel of ergonomics, I guess. And from our lecturer last month, that kind of human factors comes into it in a huge way, because certainly when you're flying, there's enough going on to not need to know where to find every dial that you need. So intuition helps a huge amount, and yeah, they're two very different setups, that's for sure. And that's B. Beaumont, a name that I'm sure you'll hear in the coming slides quite a lot. He was the chief test pilot. He's given some fantastic interviews about the TSR-2 since. But yeah, this comment is really around understanding the voice of the customer. If you're designing something for somebody, you best ask them what they want. And that's something that they never quite did with the TSR-2. Now we're kind of getting into the real technical bits of the bombing, radar, and reconnaissance. I'm not going to go into a huge amount of detail here. One, because I haven't actually seen the kit myself, so it would be remiss for me to do that, but hopefully to give everyone an idea of how much they were changing with this aircraft. The bombing, which was previously, certainly looking back to World War II, it was far more simple than what was planned for the TSR-2. They were trying to create something using a system called the Doppler inertial mix system, would calculate based on track speed, altitude, and position to ensure an accurate delivery of the payload, something that hadn't been done. FLR, which was brand new, and it was a downward and sideways looking radar, so it's a train following radar, and it comprised of an altimeter, angular stabilization, and airstream direction detector. So basically it was taking in all of the information surrounding the aircraft. Bear in mind, it could be flying at Mach 1.1 at 200 feet, taking all this information, processing it incredibly quickly, and the ultimate goal was then to incorporate and kind of slave that to the AFCS, the autopilot, for want of a better word, and the accompanying HUD for the pilot. So not only are they redefining what radar meant for an aircraft, but they were integrating it into systems that also didn't exist at the time. It was incredible what they were trying to do, and not forgetting the time frame that they were asked to do it in. From 59 to 66, it's insane. Someone, in one of the books I read, someone gave a lovely comparison of back then as well. The general view of these things was, the plane was very much 95% hardware, 5% software. And it's interesting if you compare that to nowadays, where it's probably the complete opposite. A huge amount of the investment and design time goes into the software to make the plane flyable. Interesting. Now this was really interesting. The X-band EMI SLR single lens reflex. It's the camera, right? This was the reconnaissance camera that would allow photos to be taken of the ground for its reconnaissance runs. Effectively, it would take scanning photographs as the plane went over the target. What was amazing about this system is they were trying to design it so it would develop the images in flight. You know, this is 35mm roll camera. They had a bit of kit that the camera roll would pass through. The chemicals would do their stuff on the camera roll, and the navigator would be able to study the results in flight, which is incredible. You know, to think of an aircraft pulling G through hillsides and having these chemicals swishing around, developing film down below. Amazing. And it didn't actually stop there, because they also wanted to introduce, I think it's Ferroni, the company that were responsible for it, were looking at developing the moving map display. So what this was film photos of large swathes of Europe that they were trying to get inside the cockpit so the navigator could look at real photos based on location to understand exactly where they were aiming and what the area looked like. And not only that, but they were trying to develop it so it would slave to the radar. So the radar would be able to tell this moving map display and vice versa exactly where they were, to give the pilot and the navigator real-time imagery of what they were looking at, which, you know, again, didn't exist. This is long before the days of Google Earth. And I think that's certainly something that's worth commenting on. Certainly with these things, this is a time where analog was you know, reigning supreme. Digital computers were starting to get onto the scene, and the only way to run these were on some of the first digital avionics computers built into the aircraft. But for anyone born after the 1980s, you know, it's easy to forget how much power we have in our pocket with an iPhone compared to the amount of ingenuity that went into designing these systems back then. Alrighty, so moving away from the aircraft, trying to set the scene politically a little bit here. The TSR-2 was getting more expensive as the days went on, but it was promising to be a potentially very exciting aircraft. One of the big competitors for it was the Blackburn Buccaneer. Now this was Lord Mountbatten, who was he was a Navy man all his life, and the Buccaneer was a carrier plane, an aircraft carrier plane. It was his preferred choice because for him it was in-house, if you like. It was said that the government held contempt, that they never really considered the Buccaneer for the TSR-2. As I said, the RAF disputed that, but they did very closely look at it. What was interesting, as I said, with the Buccaneer is there were worries that it wouldn't be able to offer the same flying advantages the TSR-2 would. Now, Lord Mountbatten actually, so much so was his adamancy over the Buccaneer, he would pretty much tell anyone who would listen, in this case mainly the Australians, who play a pivotal role in this story in the following 18 months. He actually encouraged them not to buy the TSR-2. Here, they kind of said that Mountbatten, who had planned a trip over to Oz in 1964, would carry 5 models of the Buccaneer and 1 of a TSR-2, and he'd put them all on the desk and say, you can buy 1 of those or 5 of those. What would you decide? The other major competition to the TSR-2 is the F-111 Aardvark, which was the government's preferred choice. It was a US-made manufactured plane, and it was one that was always looming on the horizon. And it's, you know, in the end, we'll talk a little bit more about that in a bit, but it became part of the death knell to the TSR-2 story. Here you can see the Buccaneer on the top left, and the Aardvark with its swing wing design on the bottom right. Now, it's interesting actually, under Cortland Perkins, the USA came over under the pretense that they had told the RAF that they were looking at purchasing the TSR-2. What actually happened was they came over and on a mini reconnaissance mission, learnt as much as they could from the TSR-2, took it back of all this groundbreaking technology, took it back and tried to put it in the F-111. And this is, you know, the political scene at the time. the USA are getting more concerned that the British export market, on the back of the success of the Canberra, might outbid a lot of the potential American sales of the F111. They might be replaced by the TSR-2. So there was a huge amount of pressure from the USA on British government. I wouldn't say explicitly verbatim cancel the project, but that was definitely the feeling at the time. The US wouldn't have been disappointed when they saw the TSR-2 project canned, because it gave freedom for their F111 export market to open up a bit. And in the end, actually, the Australians put in orders for the F111, as did we, but we'll talk about that in a bit. So Boscombe Down, XR219. XR219 was the first flying and only flying TSR-2 that was made. Why Boscombe Down? It's a really interesting question. Boscombe Down, it should be said right off the bat, was used for the final assembly and the initial testing and first flights of the TSR-2. It was initially scrutinised by both companies. English Electric wanted to use Wharton, which was their home base. It was ideally located because it had the supersonic corridor down the Irish Sea. This was up in Lancashire, so they could quick hop over the sea and they could test out any kind of supersonic capabilities. They also had all of the English Electric team on hand, all of which had that kind of supersonic experience. And, you know, it's their home shop, so of course they wanted it. The same was said for Vickers, whose base was Wisley, and their manufacturing shop in Weybridge. It was ruled out, Wisley was ruled out fairly early on though, because it was a shorter runway, and certainly people like B. Beaumont were worried that it wouldn't have the kind of length required for the testing that needed to be done for the TSR-2, certainly at its early stages. You want as much tarmac as possible. Needless to say, Boscombe Down was chosen. Now, it was a very healthy choice because, you know, you had, as you know, as Jeff said, you have a huge amount of experimental flight experience down at Boscombe Down, had done for many years. And certainly the understanding, my understanding from a lot of the research, is the crew were welcomed very warmly down at Boscombe Down. Despite what might have felt like an invasion of their space, they set up a shed with their final assembly line and obviously used a lot of the team down there to get it up and running. So perhaps it was definitely for the best that it did go there. It wasn't all plain sailing. As I mentioned, there were known engine issues that ended up blowing up the Vulcan flying test bed. Now, this was during taxi, not during flight, which was a relief, I'm sure, for the pilots. But there were initial worries with the engine. Taxi checks were completed on the 6th of May, and the first official flight happened on the 27th of September 1964 at 15:28. It lasted just under 14 minutes. Now, the bit of the story behind this is that the aircraft wasn't in a safe state to fly because of these known engine issues. What was interesting is there was an election a few weeks after this flight, so it was very much a political move to say we need to prove to the current government. There was a public feeling that the Tories were going to be out and the Labour were coming in. That was, it seemed almost known at the time. So they had to prove that they had a viable product. B. Beaumont took the risk on and said it's, you know, it was worth the risk, despite the engine issues, and they took it for this historic first flight, and that's the photo there of it disappearing into the skies for its few circuits around Boscombe Down. What was interesting is the feedback from the pilots was at an early stage very, very positive. They said it was an incredible aircraft that was supreme stability and control, despite just coming off the the sheet of paper, the design paper, really. And that's a photo of XR219 down at Boscombe Down. A lovely image, actually. So quickly intercede our flight testing with this, important announcement that the Labour government was elected. Harold Wilson was made the PM, and he very quickly inherited an £800 million deficit. But this was a deficit on trade, not of internal spend. But Unfortunately, that didn't seem to change the direction that the government went in cancelling projects internally to try to attack a deficit, despite it being a trade deficit. What was also interesting, one could say ironic, is that a Department of Economic Affairs was set up within the government, which was designed solely to drop a national plan to promote national investments while actively cutting national projects. So who knows? What was interesting is that a lot of the lead economists at the time suggested to Harold Wilson that the way to rescue the economy out of this debt was to devalue the pound. Now, Labour had previously done that in 1949, and he was conscious that he didn't want to be tagged, or he didn't want the Labour Party to be tagged as the party of devaluation. So instead, they sought to reduce this deficit through the culling of expensive projects, as I mentioned. Ironically, or sadly enough, the pound was actually devalued in 1967 anyway, so they ended up doing both. Right, back to Boscombe Down, where testing is going really well. There was a gap between the first and second test of a few months to sort out this engine issue. That was sorted out, and on 31st of December, the second test happened. Successive flights came pretty much thick and fast. There are 2 sorties a week from early January 1965 onwards. There's a few little teething issues with undercarriage failures. One of the big early ones that Roland B. Beaumont and Don Bowen, the chief test navigator, mentioned was there was an oscillation that matched that of the kind of natural resonance of the eye. So when the aircraft came into land, it actually caused them to lose sight for a few seconds, which is not good. That was sorted out, but the undercarriage failures did plague the team. Certainly from flights 5 to 9, where they were trying to bring the undercarriage up to complete the testing schedule. For whatever reason, the undercarriage wasn't behaving. They managed to sort the issue by installing air spring jacks. So on flight 10, with these jacks installed, they managed to successfully fold away the landing gear, and they kind of immediately upped the ante. But the first time they found these landing gear issues, there's a great story that B. Beaumont said. It was clear that the left-hand landing gear wasn't in the correct position for landing. So he radioed back to his backseat Don, and he said, "Okay, Don, here's your chance to try out your Martin Baker, which is the ejection seat." And after a long pause, Don replied saying, "You're not getting rid of me that easily." And they ended up making a safe landing to their only flying aircraft. So it was a huge risk, but it landed safely. They got the problem fixed, and what was kind of most exciting is once they fixed the landing gear on flight 10, they really opened up the flying envelope. So they did 2 cycles of the landing gear mid-flight to make sure that the problem was sorted, and then they opened up the flight envelope. So they started flying from 270 knots with the landing gear down in the previous flights to up to Mach 0.8, so 533 knots. And that included a 70-foot low pass at 511 knots over Boscombe Down Airport, or aerodrome. It should be noted that certainly in all of the research I've done, as I said, the feedback from the guys flying it and from the general team was it was performing exceptionally well. It was meeting or exceeding expectations, and for such an early test vehicle, that's remarkable. So that was the landing gear that was misbehaving, safe to say. You can also see a bit of a interesting design. Note the wingtips are reduced at 30 degrees on the edge, and that's to help combat Dutch roll, which is kind of a yaw-induced roll when rolling. Flight 14 was a particularly exciting one. That was the one and only supersonic flight, where the aircraft was said to have kind of left the Lightning chase aircraft in its dust. And B was flying it, and this was their return flight from Boscombe Down to Warton with the XR-219, the first aircraft. And yeah, they took us Mag 1.12 at 29,000 feet over the Irish Sea, and then headed back to Boscombe Down. Sorry, headed back to Wharton to kind of what felt to them as bringing the aircraft home. The remaining aircraft, 220 and the following, which were in the hangar being built, remained at Boscombe Down for their trials. Bit of feedback from B there. He mentioned how beautiful control. This was on his first flight. He was able to relax and take his hands off the controls, which for a first flight must be quite nervy. That's quite impressive of any aircraft. As I said, on the 22nd of Feb, XR209 was flown up to Wharton. XR220 was at Boscombe Down. Now, you know, unfortunately it actually fell off a lorry. The lorry jackknifed and the fuselage fell off. Now it wasn't the end of the world. They quickly sorted out the delay, but what was unbeknownst to them was the timing of these issues. They had completed initial kind of taxi trials and were getting ready for engine trials on first flight in March and April of 1965. And you know, they will find that that's particularly critical timing. And this is a lovely photo of the aircraft down at the Boscombe Down hangar. I think that's XR220 there in its final assembly stages, ready to be put through as testing. Now, one of the, if not the biggest issue that TSR-2 faced was its economics. It was a very expensive project. You know, if we've kind of learnt nothing, it's the fact that they were trying to put everything new and exciting in this one airframe. That takes time and it costs money. They were looking at a production cost per aircraft increase from 2.3 to 2.8 million, and development costs that were initially set at 15 to 35 in 67, in 68 reviewed to around 70 million. Now we're looking at 260 million development costs and rising. Not only that, but they were trying to find buyers for the aircraft. The RAF had planned to purchase 150, which seemed like a lot at the time, certainly. The Australians were toying with, I believe, around 24. I've heard some people say 30, but with a few there. Unfortunately, within a few months, they had actually changed their minds and instead went down the F111 route. Now, this was widely considered as the death knell for the project. And Harold Wilson publicly kept quoting this figure of development costs of 750 million. And with that, suggesting a potential saving of 300 million in cancelling the TSR-2 and going for the F111. So they were setting their stall out to say this is really what's going to happen, and they were trying to prove the economics of it made sense. At this point, the TSR-2 was costing roughly 4 million a week. Also, looking at the wider picture here, the British East of Suez role was being diminished as the empire was getting smaller. Within the last few years of 65, 20 colonial countries were becoming members of the Commonwealth. So there was a removing of airfields and access to supply routes that the TSR-2 could have serviced and flown. And with Polaris coming online with the Americans, the nuclear threat of a nuclear deployment vehicle like the TSR-2 was becoming potentially redundant. Unfortunately, on the 6th of April 1965, the project was cancelled. The manner in which it was cancelled, is what makes it such a sour story, to be honest. What was amazing is the Labour government that came in had promised jobs, and in a very close cabinet vote, the project was decided to be cancelled. What is awful about the story is that Dennis Healy he sneaked the report into James Callahan's budget report, and by doing that, it means it's not open for debate. It is this is happening, deal with it. Not only that, but Roy Jenkins, who was the Minister of Aviation at the time, that morning of this budget debate brought in the main contractors' managers and told them that the project was being cancelled, and they obviously requested to be able to tell their teams instead of hearing it on the radio, and they were they weren't allowed to. So you had the very real, that's Dennis Healy there, sorry. You had the very real reality of a team on the apron down at Boscombe Down who were refitting a fuel pump to XR-220 to get her ready for her first flight. Dell and Moneypenny, who are the test pilots and navigators, heard this budget speech on the radio, raced out to the apron to get the aircraft up and running and up flying to prove that they had 2 aircraft that were working. But they weren't allowed. Their paperwork was rescinded and they were blocked, literally on the apron, trying to get XR-220 flying. Is the most awful way to cancel any project. And in what's funny is kind of reading books by Jenkins, Healy, and in interviews at the time, no one can give a straight answer as to why they did it the way they did. And books, I think Hastings wrote a book called The Murder of TSR-2, and it was really that. This photo is from the Save the TSR-2 march, which went through London, went through government. Of course, the reality on the ground of this cancellation was there was thousands unemployed. Factories closed. A lot of the talent went overseas, which, undermines the point of projects like this. Very, very sad. It was said at the time, Dennis Healy said he had preference for the F-111 instead of the TSR-2. He believed that the RAF didn't need to buy British-made aircraft. He believed that the F-111, because it was being made for a larger market, was therefore bought cheaper. And he also believed that the TSR-2 was too late to meet the needs of the RAF, which I would suggest is indisputably incorrect, considering the Tornado came along 15 years later and was rocking much of the identical technology the TSR-2 was, and that stayed in service until recently. So I'd suggest that's not, history tells us that's not the case. The unfortunate reality was the cost was tripling, is what he quoted, but the cost was going up very quickly, and it was going to be late. Late to an insanely aggressive timeline, but late nonetheless. Jenkins, of the Roy Jenkins, Ministry of Aviation, mentioned, he said the TSR-2 had few friends outside the aircraft industry, and he thought cancellation was inevitable. Reasons there. He also mentioned actually that in his eyes, because the Australians had pulled out of the purchase of it, they that was the death knell for it in his mind. The economics of it didn't make sense from that point on. The aircraft industry at the time was consuming a huge amount of the government's R&D while accounting for very little of the exports. So it makes a very difficult cost argument when looking at those statistics for something like the TSR-2. Also, aircraft development projects were becoming more and more expensive as more and more technology was being invented and put into these flying machines. The costs were rising, perhaps unsurprisingly, which is why B. Beaumont, kind of looking back on this, has often said that the aircraft was too advanced for its day, which I would suggest is true. Based on this, it was the most ambitious aviation project of the 50s and 60s, maybe alongside Concorde, if not. The government weren't quite ready for it. Also, a precedent was about to be set, and was really set, that of international funding was required to make a project successful. And we'll look at Concorde in a slide or two's time. So the TSR-2 really was resigned to infamy. The F-111 was the out for the government. That was their excuse to not invest in the TSR-2. They were ordered in 1967, and they cancelled 1 year later at a cost of £40 million. So a double kick, really. The legacy was that the RAF had to adapt their V-Force bombers to overlap with the hole that the TSR-2 left by not being allowed to be completed. So they looked at low-level bombing for the V-Force. The Concorde, Roy Jenkins tried to pull out in 1964. That was obviously, that never happened. But the Harrier and the Tornado were the next big projects developed by the British government. Certainly the Panavia Tornado was a huge European effort, so it wasn't solely British. And what was interesting is it used much of the TSR-2's ideas only decades later. The Tornado, actually, its first flight was in 1974 and it entered into service in 1979. And it was reflecting much of the TSR-2's technology then. So amazing how ahead of its time the TSR-2 was. what happened with the airframes? 219 was used on a live bombing range and destroyed to nothing. 220 lives at RAF Cosford. XR222 lives at Duxford, and the rest were dismantled. And what makes this such an emotional tale, I guess, is the manner in which the project was dismantled. Everything was destroyed, everything was burnt, it was vindictive. What's interesting is neither Jenkins nor Healy admit that it was their orders to destroy the project in such a way. Who knows? But that's what happened. What was saved from it? So, for example, the engines. The 22R went on to be a cornerstone of the Olympus 593, which went into the Concorde. So that we'd like to think that was a huge cornerstone in future production for Concorde. What's interesting is, as I mentioned, Roy Jenkins and the MOA tried to cancel Concorde. The reality was they couldn't. They weren't allowed to. The costs of leaving the Concorde project from the French would have been insurmountable. So they just had to stick. What again was interesting from the American side is there was growing pressure from the Americans to cancel Concorde as well as TSR-2. And it was very sad that certainly during the early years of Labour, Harold Wilson, as I mentioned, there was an argument over whether he should devalue the pound or cut projects as a cost reduction, and in the end he ended up doing both, and the TSR-2 suffered because of that. Funnily enough, the Americans were developing a Concorde equivalent at the time. They had to cancel it because of cost, and in the end the 747 was the output from Boeing that has obviously reigned the skies up until this year because of COVID. So reflecting back on what was a fascinating research project for me, and obviously seeing the aircraft in the skin as a pilot was brilliant to see. But I don't think it would be beyond scope to say that if the TSR-2 had been allowed to fly and prove herself in the sky those early years, variants of it could well still be flying today. There would certainly be less requirement for the Tornado. And really, to summarise, because thank you very much for listening, but to leave you with one quote, which was Sir Sidney Camp. He was the chief designer at Hawker. He retired in 1965, so just after the TSR-2, and actually died in 66. But he left this fabulous quote. He said, "All modern aircraft have 4 dimensions: span, length, height, and politics." And TSR-2 simply got the first 3 right. And that summarises my little story of my version of events of the TSR-2. Thank you very much for listening. I really appreciate it. And if there's if you're interested in anything more, please do. There's a wealth of information out there, a wealth of books, and yeah, it's the most incredible story. Thank you.
Thanks very much, Joe. Really brilliant talk. Yeah, so thanks again. We've got a few statements, I think, on the Q&A, as well as some questions. So I'm going to try and pull out the questions, and then I'll go through some of the statements as well. There's a picture there about the undercarriage bogies being at different angles during the first flight. Why so? There is an answer, I think, kind of mentioned later on, but I'll let you answer it yourself if you want to.
Yeah, I believe so. They had designed the bogies to fall under gravity with the help of the air to kind of help them drop. Now, for the first few flights, they actually didn't mess around with the undercarriage at all, which I think is why they had issues from flight 5 to 9, because the first 4 they didn't. You tend not to pull up the landing gear for the first few flights of any test flight, because it's one more thing that you don't need to go wrong. I actually don't know the answer, but having had a look at modern aircraft on landing, all the wheels don't often sit at the same angle, but they quickly right themselves on traction with the ground. So I would imagine it's just how they were lying with the air against them.
Yeah, I think a bit further down here there is a comment somewhere, I can't quite find it at the moment, about the fact it's actually to do with the air loads as well. Next question is from Hugh Thompson, who asks, if who actually, though you mentioned Healy and Jenkins, but who actually ordered the destruction of all the everything, you know, the blueprints and all the ephemera that went with the airframes?
It's a great question. I'm not sure I know the answer. I'm not convinced I found the answer. As I said, both Healy and Jenkins were happy pointing the finger at anywhere but themselves. They have explicitly said in interviews since that they did not order the destruction of the TSR-2, but they didn't say who did. So that's one thing I'm yet to find. So if anyone knows, please do let me know. But I am unaware.
Okay, and then the next question then is, what was the trade-off of load speed range like? This from Neil Spalding, and he sort of kind of infers that it actually wasn't that good, and I have to say that I had read at one stage that they were struggling a little bit with the range of the aircraft, and someone, maybe it's apocryphal, said that, you know, the last mile will cost you a sort of, you know, £1 million every mile or something.
Yeah, I mean, certainly from what I kind of gleaned from research was to be able to take the design for the TSR-2 came out a lot bigger than they had anticipated, and that's because they had to carry a lot more fuel than they had anticipated to make sure they could get the distance they wanted. And this kind of goes back to the whole designing an aircraft to satisfy the requirements of every customer. To be able to get something that flies very fast, high and low and far is a very challenging concept, and at the time they wanted to do it without in-air refueling, which is what sustained things like the Vulcan bombers at the time. Was the only way they got range was through in-air refueling. So I'm unsure, to be honest. I would imagine that they were relying on the in-air refueling for very long sorties. And they were looking at underslung fuel tanks as well for the wings that weren't tested because they never got the opportunity to test them. But it was just, yeah, it was one of the design challenges of speed versus weight. And again, looking at the landing and the vertical or the short takeoff and landing was a massive design challenge to overcome.
There was a question from Joni Pelham about more detail regarding the optical line scan reconnaissance system, which I think you did mention. You talked about that and the wet film as they went along type system.
Yeah.
I don't know if you know any more about that. Someone does actually also make a comment a bit later on that apparently that idea wasn't, you know, had been tried out elsewhere, I think on news cameras and things, to try and get footage more quickly.
Yeah, what I found interesting about, I believe the company that was developing was called Ferronis.
He was Franti.
Sorry, Franti.
Yeah.
That's it.
I think
Yeah.
it was Franti.
Yeah, that was the one. What was interesting about that particular system was putting it in an aircraft that was flying at Mach 2, you know, low level, or pulling these incredible G-turns. You know, that's kind of the thing that's easy to forget when you're looking at an aircraft on the ground is the systems that go into it are all well and good, but when you're putting an aircraft through G, the whole thing is stressed, the whole thing morphs and moves. So having something like a camera that's live developing film with wet chemicals, you know, sloshing around the place, albeit in an enclosed system, is amazing. I'm not going to pretend to know a huge amount more on the technical detail of how that system works, but I would certainly encourage, there are a few very good books out there which should answer that question. Okay,
the next question is from Bill Tyek, who he says, my understanding, but I can't remember the source, is that what sank the project was also the problems with the digital computing power. And later on, the F-111 had further problems, you know, with developing the technology you talked about. Do you know if there were spiraling costs being driven by the computing as well as other things?
Yeah, the computing was, I think, I can't remember the name, it began with a V, but the Brits were developing. It was one of the few bits that the Brits made. On the computer systems. A lot of the avionics, my understanding, was subcontractors, mainly from Europe. But what was I've lost my train of thought. Sorry. What was interesting about it? They never really got the opportunity to test them in anger because the flight development program never got to that stage. a lot of people, even including Beaumont, looking back, said that there would have been, even the kind of coming to getting the aircraft to service, they predicted it would be kind of early to mid 70s, because the avionics had a long way to catch up, a long way, you know, a lot more than the airframe did, which was becoming more evident as they flew it, because it was behaving incredibly well in the air. The avionics weren't at that stage, and that, to my understanding, would have been the kind of long pole of developing the project.
Yeah, because you comment on that. Someone actually comments on the fact that, you know, there was quite a lot of work to get similar kind of systems working on the Harrier, GR1 and GR3, and obviously, as you said, the Tornado finally cracked some of the technology. Question here from Graham Ennis. Did the TSR-2 ever land or take off from grass or an unprepared surface?
It didn't. What it did land, what they were trying to do to isolate this landing gear problem, because, like I mentioned, there was another landing gear issue, which was the bogies on contact with the runway would oscillate because they were so long to accommodate for this mixed field landing. Because they were so long, they would oscillate at a fixed frequency that would oscillate the whole of the front fuselage, so the pilots were getting shaken from back to front as well. In order to try to rationalize where the problem was coming from, they got the fire engine, the kind of fire services at Boscombe Down, to cover the airfield, the runway, in foam to reduce the static friction, to see if they could isolate the problem. To my knowledge, that's the only the only surface they landed on which wasn't pure tarmac. So I'd love to have a double check on whether they landed on grass. I would be very doubtful that they did at that stage in the test schedule.
Sure. Okay. Just moving on. A question from Tim Gosling. Says the story goes that Wilson's government were given a choice between funding the TSR-2 or Concorde. With hindsight, would you say what would have been the best which, if you had to do it, which one would you have gone for? And you're not allowed to be biased.
That's a horrible question. Very, very tough. I mean, both were revolutionary in their own right, weren't they? I think it's fair to say that a lot of the learnings of TSR-2 went into Concorde. I mentioned about the 593 engine that went into it. You know, a lot of the early error finding was done with the TSR-2 to the Concorde's benefit. It's interesting that his understanding was they were given a choice, because my impression is they wanted neither. They wanted to cancel both and get rid of it. Get rid of both, sorry. So I can't really answer that. I mean, the Concorde proved to be an iconic, incredible aircraft, and I couldn't imagine a world without it. But equally, that's simply because I can't imagine a world with the TSR-2 having not seen it. Sure. So I'm afraid I both.
Simple question as to who developed the train following radar. Do you know who that was? I
don't. I'd love to know, but I don't. I'm afraid.
And then there's a question here from John. Says, however, do you not think it was inevitable that with a massive rise in costs that the project, you know, should have been cancelled? I think you reflected on this in the massive economic problems for the country, but
yeah, I think B. Beaumont summed it up very well, in that it was more aircraft than perhaps the world was ready for, and I'm sure a huge part of that was the cost. It seemed, what I would say is, I don't think they helped themselves out. When they set up a project between two companies that didn't want to work with each other and a government overarching every single decision, they built in a huge amount of cost, delay, and unnecessary kind of development, red herrings. So perhaps no, it wasn't. It was inevitable. Sorry, that it was going to be cancelled due to cost, but they should have seen that coming in 58, 59, not in 64, 65.
Staying with the finance side, someone asked a question: Are all your figures? Which values are they at? Are they presumably they're figures of the time?
Of the time, yeah, you're right. I should put a conversion table in. They are figures of the time,
because they would be eye-watering now.
Yeah. To give you an idea, the MOA's budget annually was 200 million. and the TSR-2 was reportedly costing at the end 4 million a week, which is pretty much the whole of the MOA budget. So that gives you a sense of scale for how expensive the project was becoming. There are one of the interesting things is no one really knows how much the project cost. There are talks about at cancellation it cost 250 million. Harold Wilson in his speech kept quoting 750 million of development cost. And you know, if we have that benchmark of the MOA being allowed to spend 200 million a year, that gives you an idea of where TSR2 fits within the national budgetary allowance. It was very expensive. Yeah, very, very expensive.
I think you covered this about how, you know, do you think it forced the multinational approach going forward?
Yeah,
projects.
Absolutely. Whether it forced it or whether it was happening concurrently, and TSR2 just got it slightly wrong in not jumping on that bandwagon a few years earlier. Perhaps that's you know, that's one of the reasons it didn't quite work out. And as I said, I don't think it's any secret that the Concorde succeeded, or you know, the Brits stayed with the Concorde because they had to. And you know, as you wind the clock forward, even to today, with the F-35, Trump did his best to try to shut that project down, but you know, the F-35 had an incredibly intricate international supply chain. Rolls-Royce making the parts of the engines, parts of the VSTOL lift system there, big contracts out to Japan and you know, all across the world. The point is, I think when you build a supply chain internationally, you do add intricacies, but you add security because it's a lot harder for people to back out. So it'll be interesting to see what happens with Tempest now, which is, you know, it is going to be a post-Brexit Britain-only project. It's going to be interesting to see how it plays out really, and whether, I hope not, but whether it follows the paths of TSR2, and will we learn from what's happened before and how we go forward.
Last couple of questions I think we've got time for. I think you said, you know, TSR2 brought a lot of revolutionary technologies. We've mentioned the fact that some of the avionics ended up in the Tornado and the engine in the Concorde. Was there anything else that you know about that went anywhere particularly?
I would love to be able to answer that question with a huge amount more detail than I have, because I'm sure I would be very surprised if, as you said, things like the avionics weren't all upcycled into the next best thing. You know, that's certainly what I love about aviation and engineering, is you tend to learn from what's happened and you improve upon it. What I do know is some technologies, things like blown flaps, ended up, I don't know that they died with the TSR-2, but I am fairly confident that blown flaps kind of stopped in the 70s because of the risk that dust would get into the outlets and they would block the system. And if you have any kind of engine problems, blown flaps don't work. You need that pressure supply from the engine. So I am aware that the aviation industry started to move away from some of the ideas that were in the TSR-2, but I'll be confident in saying that a lot of the technology that went into it was developed ongoingly over the next kind of 10 to 20 years. Okay,
I'm going to wrap up with a very last intriguing question and thing here, almost like it's almost slightly conspiracy theorist there. So apparently there was an effort to revive the TSR-2 in the 1980s using updated avionics and Tornado type intakes. Do you know anything about this, and who it was who thought about this and how they thought they could back engineer everything?
I don't actually. That's new to me, and I'll definitely go away and do a bit of a research on that. My comment would probably be, you know, if looking at how hard people have worked to keep the Vulcan flying, I'd be surprised, you know, if a project like that would ever be successful. I mean, the cost of keeping the Vulcan flying is, you know, is proving insurmountable, isn't it, with the charity? But yeah, interesting. I'll go and have a look at that. I wasn't aware of that at all.
Okay, so I think we'll sort of wrap up there. There are quite a few comments which hopefully people have seen on the Q&A published, saying of some very useful and a commentary, I think, against you know, what you talked about. So Joe, it's been absolutely brilliant. I mean, for instance, someone there's talked about, you know, the question you mentioned about the HMI, and you know, the sort of the problems with trying to export it. What else have we got here? Systems Design Authority was a chap called Harry Zeffert of BAC, and he apparently you can read his recollections in 15 taped reels of interviews in the Imperial War Museum. So
Oh, wow.
if you haven't been there, I guess that's something for you, something for you to do next.
Yeah.
He went on to work on Concorde, and also Martin Powell recommends the RF Historical Society Journal 70A report on the TSR-2 with hindsight, which you can download from their website. So we can certainly, Joe, as I say, there's some stuff there which would be obviously, hopefully everyone can see there, and also we'll share it with yourself if you can't get any of that. But I'd just like to say on behalf of the branch, a tremendous thank you for it. Huge interest tonight, this evening, on the subject. I think it will always remain so. As I say, remains quite a special aircraft for Boscombe Down's history. And we did feature it in our first flights calendar, which is back in 2016 now. But yeah, so there are images there, and I'm sure if you're looking for anything more from our archives, you know, we'd be pleased to have a separate discussion about that. But so thanks so supremely on that. I don't have a means of doing this yet virtually, but we do have a little glass block, a memento for you to say thank you for that, and one of those will be winging you through to the post, in the post. So thank you again so much, and we wish you well in your continued career in aviation, and thanks again so much. Really great talk.
But no, thank you very much. Thanks for all the
thank you everyone
and comments.
Good, excellent. Thanks everyone also for joining us this evening, and we look forward to you joining us again in a few weeks' time for our next lecture about that helicopter with the and fitting weapons to the helicopter. Okay, thank you. Good evening.